Let's have a look at the winners of the mnemonic device contest for classification groups, which remember are domain, kingdom, phylum, class, order, family, genus, species, and you have to memorize those for the test. Let's give you some tools to do that with. I showed you my remote winners already. Derpy koalas persistently cried out from growling stomachs. Don't kill Phil casually. Or Fat Gangsters Sue, which I think was your favorite because suddenly all of your submissions started to look like that. And Dirty Krabby Patties cooked on Fridays. Geez, SpongeBob. Your winners. I decided to take 3 from each class. Okay, so don't kill penguins because owls fit to get suspicious. Dinosaurs keep purple crocs on forest green shelves, and don't kill parrot because of fungal growing sickness. Second period's winners. Don't kick pedestrians because older folks get suspicious. Didn't know people could obsess over good science. That's quality right there. And Dancer Kate and Perry cart with Fran's garden shovels. My point is, pick one. I don't care which one, but you're going to need something to remember this by. So this one, these, or these. What do you prefer? Which screen do you want me to leave up for you to copy down? This one? You like that one? Okay, well, take what you want from this one. You might want to do it on the page that has the actual answers, you know, domain, kingdom, phylum, class, order, family, genus, species. If one of the first period winners was you, I recommend using your own because you'll remember it. Yes, Ryan. Oh, yes, definitely. So here's first period. Anyone want to write one of those down? Second period. So that's thing one. Thing two is you will not have a test tomorrow. Thing two is you are going to have a test on Tuesday. Tuesday. Eventually. Probably tomorrow. Grab your notes. Let's finish this up. One of the things we know from the fossil record, and you're about to get a much closer look at that through something you're going to watch, is that every once in a while, most of the living things on Earth die. Sometimes really spectacularly. Sometimes less so. 5 times so far. 5 mass extinctions have occurred in the history of this planet. The first was the one that happened because of oxygen. Right? We talked about how single-celled organisms, once photosynthesis develops, that oxygen they produce by succeeding so much spreads out and basically kills all the stuff that can't tolerate it. That's the first mass extinction. Maybe the least exciting for us. There's been 4 others. Obviously, they suck for the critters that are living at the time. But things get real interesting afterwards. You know, whatever the cause is, and there have been mass extinctions because of space impacts. That's the one you'll learn a lot more about today. The super volcanoes all going off within, you know, a short time of each other can kind of fry everything or block out the sun. Various causes, but what tends to always happen afterwards is that whoever makes it, whichever species don't go extinct, kind of get to play. Because suddenly there's all these niches. Remember niches, the way organisms, the way species fit into their environments. Well, suddenly there's not so much competition for those niches, and those niches are open, which means a lot of species getting to spread out. A lot of species changing their environment, moving to new places, and of course that's going to speed up evolution a little bit. The process of surviving species spreading out into new habitats is called adaptive radiation. Right. Radiation as in spreading out from a central point, not radiation as in, you know, gamma rays. And this turns out to be a really important pattern in evolutionary history, and it basically has helped scientists explain a couple of things, because Darwin's ideas about evolution were very much like, hey, this is all slow and steady. This is all bit by bit by bit by bit, same rate the whole time. Descent with modification at the same speed. But that's not what we saw in the fossil record. What we observe in the fossil record is that there's these kind of long periods of very slow change like Darwin thought, and then there's these periods of, whoa, fast forward, right? And of course, the one where sex evolves makes sense. But what about the others? There's all these gaps in the fossil record that scientists had a hard time explaining. Well, adaptive radiation and mass extinctions kind of came together to help scientists rethink Darwin's idea of what he called gradualism. And that is where we get that essay question. The theory now of the idea that the Earth's history is punctuated by mass extinctions, and that there's these periods of equilibrium in between those mass extinctions that punctuate the Earth's history, is called punctuated equilibrium. Right? It's just that, yeah, things are pretty slow and steady until disaster strikes and changes the rate at which things evolve. Long periods of stability, that's the equilibrium part. Very slow evolution. You can see, you can find critters out there that haven't evolved, haven't changed a whole lot in millions and millions of years. A horseshoe crab, cockroach, relatively unchanged. So where do all these new species come from? Where do these jumps in the fossil record come from, where we see new species showing up? Well, that's the mass extinction part. Those periods, we found, tend to come right after evidence of widespread catastrophe. Those periods are when we see most new species forming. The really interesting thing about the mass extinctions is, of course, that we weren't around for any of them. And so it's hard to know what things were actually like when, you know, for example, the dinosaurs went out. And there's been a lot of different ideas about that, a lot of them conflicting with each other. The current science on it is much different than it was when I was a kid. When I was in high school, basically, I was taught, well, there was either it was volcanoes or it was an asteroid. But either way, what happened was the sun got blocked out and everything kind of stopped. Current research has shown that that is almost certainly not the case, that the truth is much more violent and sudden. And I want you to see some of that science, and so I'm going to make you watch something. It's actually the same podcast that you listened to before about CRISPR, but this one is about the dinosaurs going extinct, and it's actually a traveling show version that they did of their podcast. So it is on video, for better or worse. I listened to it first on audio. I don't know which is better, but you're going to watch the video. So go ahead and log in.